So I'm going to take a little bit of a different approach on economic value of manure, because everybody here knows what the fertilizer value is. So I'm going to just go through and start with the premise that the cost of manure handling is a cost that's associated with the livestock business. You've probably heard me say that before. But the better job we can do of maximizing the nutrient use of that manure, the better the bottom line for the livestock farm. And so I'm going to start off with a slide that basically takes over from where Mike left off, and then from there go into where we can look at the economic value. So this is taken from the Weather Network. It's a map of the actual temperatures and rainfall that occurred in the first couple weeks of January up to yesterday. And in red, because it's hard to see, in red that's the amount of rainfall, and then you can see the temperatures. They're pretty easy to see. Basically, January the 1st to January the 10th, we had a deep freeze, negative a lot, it was cold. About 25, this is near London, this is from near my place, 25 centimeters of snow, or of rainfall equivalent in that snow. Then from January the 10th to January 13th, milder, enough that the snow melted and it was rain. 22.4 millimeters, basically is rain. And probably a lot of that snow melt also ended up. So Bruce Kelly sent out a message, an email to the peer-to-peer review committee, and it said, folks, as I look outside on this very dreary Friday, so this was last Friday, rain is still falling in Guelph, and our snow has melted and run off. I'm reminded of the importance of the peer-to-peer project. We started to get a few reports of manure spreading this week, some official reports through OMAFRA channels, and just some images on Twitter and pictures emailed to me from associates that know I'm involved in the project. This is the important part. Consider that any and all manure applied in the last 2 weeks just ran off into a waterway someplace, but not 1 liter of it went into the soil it was intended for. That's the reality check. In other words, the value of that manure, 0. The cost, application, fertilizer replacement, and whatever environmental consequences. So that's just a follow-up on the importance of not winter spreading if we're looking to maximize economic value. So when I look at the economic benefits, what I'd like to just consider, I'm not going to go without talking a little bit about the fertilizer value, the nitrogen, the phosphorus, the potash, the sulfur, the calcium, some of the micronutrients. The economic benefits to the soil, organic matter, a lot of you have heard me talk about that before. The economic benefit to the environment, and then the manure value to consultants. So those are the 4 things I'm going to cover in the next few minutes. You've all seen these kind of slides before. There is economic value to the fertilizer. That fertilizer value changes. And I don't think it's changed over time, that the more expensive the fertilizer is, the better the nutrient management that happens on the farm. You've seen this slide before. This one is not totally up to date, although the fertilizer prices haven't changed that much over time. But every livestock type has a little bit different nutrient content. And there are similarities between the types, but it really does depend on, is it finisher manure, is it SEW sow manure, is it dairy manure liquid, is it dairy manure solid, is it poultry broiler? It does make a difference on that nutrient content. But when we look at that nutrient content and we look at fertilizer replacement, we look generally at what is the usable amount of nutrients in that manure, and what is the value in the year of application and the value in future years. So in this case, we've got the 40% of the phosphorus here, and the other 40% is here, and then the nitrogen value in the year of application, the phosphorus value. And this represents the organic nitrogen that comes available over time, and then that second half of the phosphorus. So you can see that there's a difference. Horse manure is not as valuable as say, poultry broiler manure, but manure has value. It has nutrient value, and if you look at the organic matter and the micronutrients, it's going to be even higher. There's also micronutrients. I would prefer that this slide not get shared when you look at it on the website, because there's so much variation. I did this background information just to show people that because nutrient use efficiency in livestock is not 100%, then depending on what the ration is, you're going to have some of those micronutrients end up in the manure. And for some of the livestock types, that micronutrient content is significant. The trouble is, if you're trying to get a dollar value from that from the farm, if you don't have a deficiency, then sometimes it's hard to pay for those micronutrients. Sulfur would be an exception. In some cases, calcium would be as well. But there's also an economic value to the soil. And some of you have heard me talk about this before, and I've got a lot more information on this if you want, but soil organic matter levels cannot be built or maintained in crop rotations that include multi-year soybeans. When we look at soil organic matter levels in Ontario over the past 20 years, they have gone down faster in areas where there's a lot of soybeans grown compared to where you've got diverse rotations with a lot of manure. So where you've got a lot of soybeans in rotation, we're generally recommending more diverse rotations, cover crops, and of course, organic amendments and manure. And the assumption when I make this statement is that if you have a 3% organic matter, or a goal of that, and just in nature, just the natural environment, about 3% of the organic matter that's currently in the soil decomposes. Now that's going to be higher the more tillage you've got. There's other things that make that number a little bit flexible. But if 3% is assumed to decompose every year, and there's 2 million pounds of soil in a 6-inch profile, then we basically need to add 1,800 pounds or 1,800 pounds of organic matter back to replace just what's lost to that decomposition. And soybeans don't do it. They don't add enough to continuously do that. Corn does. So if we've got a corn, soybean, wheat rotation, then we can maintain, maybe even build organic matter levels. But where we've got a lot of soybeans, we need cover crops, we need manure. And I'm going to say there's an economic benefit to manure in the environment. And basically it's looking at it from the opposite. What does it cost when manure has a negative impact in the environment? So for example, if we've got high phosphorus levels and we've got algae blooms, what does it cost to the fishing industry? What does it cost for tourism when there's so much algae that people can't go swimming? Or what does it cost for waterworks? And I'm sure we could get some answers from Toledo, Ohio, when they had that big incident a couple years ago. Nitrogen. What happens when we've got nitrogen in groundwater? It costs municipalities a lot to deal with that. What about greenhouse gases? We probably don't have a good handle on it, but if we've got a lot of nitrogen in the soil in the spring and we get nitrous oxide emissions, eventually we have to deal with that in the greenhouse gas policy. And then pathogens. We don't talk about pathogens very much in presentations like this, but if we get pathogens in water, what does it cost to deal with them? What does it cost tourism? What does it cost healthcare? And we just have to look at Walkerton to look at the healthcare part of it. So the most of the time I want to spend on looking at the economic benefits of manure to consultants, to you. And you're an integral part of making nutrient management work on the farm. And my question is there a bigger role? Is there a bigger role for nutrient management consultants? And so I want to spend a little bit of time talking about neighborhood nutrient management plans. If we don't want manure to be applied in the winter, and we're trying to reduce the amount of potential phosphorus loss or nutrient loading, then can we look at moving manure from areas where we've got high fertility levels to areas where we've got low fertility levels? There's a lot of farms where you're doing nutrient management plans where the farms near the storage have pretty high soil test levels. And by pretty high, I mean over 30, probably closer to 60, and in some cases higher than that. And in those cases, can we take manure from there and take it to a cash crop neighbor that doesn't have access to manure? And I don't know if this is maybe pie in the sky thinking, but I think it's an issue where the time has come where we can look at it a little bit differently. And so some of the key components to this are, we have to have landowners with neighbors where they don't have issues with each other. If they've already got a fight going about the water across their farm or about fences or whatever, probably not going to work. Livestock farms with high fertility in fields close to the storage, where any other land base is quite a distance. Crop producers in the neighborhood that have lower fertility levels, and no access to manure. It's really important that there's a consultant coordinator, somebody that does the sampling, somebody that does the nutrient management planning, and not official nutrient management plans for approval, but the planning for that neighborhood plan. Application for scheduling, the paperwork, the part that makes it happen. And then the question is going to be who pays, and we'll talk a little bit more about that in a few minutes. So if I look at, this is a manure value, looking at the available nutrient from swine SCW versus swine finishers. And so if we have fall applied or spring applied, we've got about 16 or 33 pounds of available nitrogen, 11 or 28 pounds of phosphorus, 12 or 29. So that's a big difference in the amount of nutrients. But if we look at what is that value in a low fertility field after application costs are considered, and here the application cost was considered to be 1.5 cents per gallon. And if we apply a rate of 8,000 gallons for the SEW or 5,000 gallons for the swine finisher manure, then that value is $16 per acre or $127 per acre, depending on which type of manure. So that's fairly significant. The thing is, though, if I've got a farm that has high fertility values, then yeah, on paper it looks good that my manure might be worth $127 per acre. But is it really? Because if I've got high fertility levels, how long is it going to take for that phosphorus to actually be used for the crop? It's going into a bank, and it's a bank account, but that bank account doesn't really accrue those nutrient values because there's already enough there. So if I look at that full table, this is a bit to look at, but if I look at that full table in the same two fields, then if I'm looking at a high fertility field, basically anything over 30 parts per million for phosphorus, then I'm looking at a negative $58 for the sow manure, or only $6 per acre of value for the finisher manure. Because the rest of those nutrients are going into the bank, but I'm not using them for the crop. So if I'm the livestock farmer and I can sell that manure for that value to my cash crop neighbor, then suddenly I have a little bit more income, or potential income. So how would a neighborhood nutrient management plan work? Well, developed cooperatively with livestock and cash crop farms. Third-party nutrient management or 4R consultant would complete the paperwork with the maps, the crop rotation schedules, the manure analysis, soil tests from the cooperating farms. A plan would aim to distribute the manure from areas of high fertility to low fertility. Manure analysis would predetermine the value of the available nitrogen, phosphorus, and potash, potentially the sulfur as well. And you could explore, if this was something that was longer term, and if we get a program, for example, the new GF2 that's coming out, and I have no idea what's in it, but if there was opportunities for some equipment or for some new technologies, then maybe something like additional storage facility on a cash crop farm, or a pipeline that goes to the middle of a farm area, central location, or other ideas where you could take that manure at a lower cost than transporting it roadwise and distribute it over a larger acreage. So I made this map just to give you an idea. So this is in my neighborhood. I thought I would, because I know what the farms are and I know what the crops are. So if you've got a good distribution, then you've got wheat fields where potentially the manure could be applied after wheat harvest in conjunction with cover crops. You could apply it ahead of corn in some areas, or side dress it into corn. You could apply it after soybean harvest in some fields where it's not going to be planted to wheat. You could put it on forage fields, especially if you've got a high liquid, low nutrient value manure. And so there's opportunities within an area where you've got livestock and cash crop farms. And this whole idea came up because I was trying to ask my neighbors if I could buy some manure from them. And all of them know the value of the manure, but they don't realize that maybe they're going to get more money if they sell it to their cash crop neighbors. So crop rotations would be considered in the application plan, ideally applied during the growing season to minimize compaction, maximize nutrient efficiency, potentially opportunities to apply manure into a growing crop after wheat harvest with cover crops. The benefits: manure can be applied to fields that require the nutrients and or require the organic matter at times that maximize nutrient utilization. Low-value liquid manure could be applied for water benefits as well to forage fields. Low-value solid manure could be transported to potentially horticultural crops that need the organic matter or to low organic matter fields. Farms receiving the manure, they could trade straw and or pay the cost of the fertilizer equivalent value of the available nutrients, and in exchange they're getting the organic matter and the micronutrients. And then the farmer that's got the manure would get the NPK, available NPK value. Application costs are going to depend a little bit on what is the distance traveled between the storage and what is the method of application. The livestock operator receives financial benefits for nutrients that would otherwise take many years to provide payback. And consultants, like I said before, are integral in this because they help with the planning, the record keeping, the sampling, the nutrient balancing, and would be reimbursed through this plan. They're an integral part because most farmers don't have time to do this amount of planning to make the manure work. And in the past, we've seen a lot of nutrient management agreements, and how many times have we heard farmers that signed the agreements but never got any manure? So I think the consultant is the key part to making this work. And if we look at this kind of a plan, and it's not going to work everywhere, it's not going to work for everybody, but if we look at this kind of a plan, there's a lot of policy issues that are addressed. For example, environmentally, if we can apply manure during the growing season, or at least not in the winter, then we can reduce the potential phosphorus loss. If we're applying nutrients to the fields where those nutrients are required, as opposed to where there's already high levels of fertility, we're going to balance that phosphorus a little bit better. Potentially reduced nitrous oxide emissions, nitrous greenhouse gas emissions. If we can apply the manure where at a growing season, time when we don't have those risks of nitrous oxide emissions, when soils are saturated, when they're cold, when you don't have the microbial activity, then we have a better chance of sequestering those nutrients. And then also diversion from the organics. This isn't only manure, this can also work with organic amendments like biosolids or compost or some of the other materials that are available. And anything that we can divert from landfill onto farm is a benefit for organic matter levels in the soil. From a production perspective, increased use of manure, municipal organic amendments, improved nutrient utilization, opportunities for synergies with cover crops. We've seen in the past where if you apply manure and you've got cover crops, we get more cover crop growth, we get higher yields than where we just apply manure by itself or just have cover crops by themselves. Improved soil health, if we can reduce compaction by applying manure when the conditions are fit on the fields that are fit, then that's going to improve our production potential. Promotion of new manure application and GIS technology. In some cases where manure equipment might not be available, the use of custom applicators through Opaca or other custom applicators will give us an opportunity to try new technology, let the farmers see what would work on the farm. Can we apply it into growing crops? Do we have other opportunities? Even something as simple as using nitrogen inhibitors. We need to do some side-by-side comparisons to see, do nitrogen inhibitors let us extend the application season for manure without losing nutrients? We need side-by-side, so if any of you are interested in doing some of those side-by-sides, there are some nitrogen inhibitors on the market now. And then reduced application of manure on snow-covered soils or frozen soils. And then also this kind of nutrient management planning on a neighborhood basis would help with that industry 4R strategy or stewardship, where we're trying to get more of that manure applied, right time, right place, right rate, and hopefully the right source. And so with that, if there's any questions, it's an out of the farmstead idea, out of the box idea, but hopefully it has some potential in some neighborhoods.
Any questions for Chris? You must have answered all their questions, Chris.
That's not a good sign. No, everybody's ready to go home.
Thank you very much.
Andrew has a question.
I was just going to ask if you know somebody that has done this successfully.
Not on this, so the question was, do I know anybody that has done this successfully? Not the whole part of this, but there are farmers that have had manure agreements that actually worked with their neighbors with the manure agreements. Some pork producers, they had, they applied their manure to wheat fields in the spring, and then they basically skimmed the top of their manure storage, and then the area, the part of the storage that had more solids, higher phosphorus levels, they transported to the neighbors after wheat harvest when they had a little bit more time. So they did that very successfully. I don't think they got paid because they needed to get rid of the manure. I think this is going to work a lot better when there is some financial compensation for the nutrients and for the microorganisms, for the micronutrients and the organic matter component. And it would be nice if we had a dollar value for that organic matter, but that differs from farm to farm depending on where you're at.